And there's a lot of information that is on this schematic sheet itself, and we need to know what it means to us as a programmer. So I'm going to start at the bottom here. We have a hand-operated valve right here, which is actually the on-off control for the air. So we can turn either the air on or the air off. It then comes into a component known as an FRL, which is a filter, regulator, and lubricator. And then from there you can see it's distributed throughout all of the actuators in the actual station. And an actuator is just a name for a linear device. We're going to get linear movement out of each one of these cylinders. So we follow the lines up, and the first thing that we come into is the horizontal cylinder. Okay, if we look at the valve, we can see that it has two boxes. Those two boxes mean that it only has two positions, so it's either going to be in one or the other position. So if we follow the valving right now and the air supply coming in, we can see that we have pressure coming here from our FRL. It goes up and it goes through this port, which is connected right here, goes through the valve, and then it goes on through what is known as a metering device right here. This is a flow control that allows us to meter the amount of air in or out. So we have a restricted orifice right here, and the next one we have a ball and seat. So the air is typically going to want to blow the ball off of the orifice because it would require much more energy to go through the restricted orifice. So it takes the path of least resistance. So we blow the ball off of there. We have air that enters the cylinder cavity right here. And when that does, it will force this cylinder to extend. So as you can see, that's why it is drawn in this formation right here with this cylinder actually being extended. So this is the normal position of this valve. Now, if we look over here on the left side of this valve, we can see the electrical coil with the square with the triangle through it. It says A+ on it. When we apply an electrical signal to this valve, this envelope basically shifts over to the other side. So what we do then is we follow the air paths. So the air would then come through here, then it would go through this side, okay, and then finally up through the metering device, and again going through the flow control because it's a path of least resistance. It's going to blow the ball off. And with this cylinder already being extended, now air is going to travel through here, forcing it to retract. And as it retracts, the air is going to come through here. And now you can see that it's going to hit this device right here, which is our flow control, and it's going to force that air through the metering device, giving us speed control of the actual cylinder. Now, this valve here is really important compared to all of the other valves, because if we look at it, we can see that it actually has two coils on it. We have a coil here, and we also have a coil here. So it takes a signal to both extend and retract, and it's going to remain in that position. Okay, so the next cylinder that we want to look at is our vertical cylinder. And notice that it still has two positions, just like all the other ones. If we follow the air path to it, we follow it along here, it goes through the valve, and again forces it to be retracted. This cylinder is shown in a retracted position in its natural state. So with this valve here, it takes an electrical signal to extend it. So if we were to apply 24 volts to this coil, we can force this box to shift over, or actually the spool inside the valve is what actually does the shifting, but then the flow paths would be reversed. So the air would then enter this port, it would go up and it would travel through the flow control, blowing the ball off the seat, entering the blank end of the cylinder, forcing it to extend. And as it extends, all the air is going to be blocked by the ball and check now, and then is going to be forced through the metering device, again allowing for speed control. So in order to get this cylinder to shift back, the only thing that's required is we remove the electrical signal from the solenoid. So this cylinder here takes one signal to both extend and retract. Over here, compared to the other cylinder, which is the horizontal cylinder, it takes a signal to extend and a signal to retract. One thing that you need to be prepared for is to make sure that you don't turn on both solenoids at the same time. You will destroy the valve. It will cause it to overheat and it will burn the coil up. So you have to make sure that you prepare for that in your programming. Okay, the next thing that's really important about both of these cylinders is if we look at the actual top here, this is a magnet reed switch. So it tells us that each one of these is going to be activated by a magnet, and it also allows us to know positioning of the cylinder. So here, the magnet is inside here on the piston. It would trigger this switch, which is then going to trigger our input that we've seen on the previous page. So here on the horizontal cylinder, we have extend and we have retract. On our vertical cylinder, we have the same. We have extend and we have retract. Okay, on our suction cups, we have a vacuum generator over here, which will then trigger our vacuum switch. The rejection cylinder is a little bit different style cylinder than the other cylinders that we saw. This is known as a single acting cylinder spring return. So again, it has the exact same style valve that the other ones had. It's a two-position valve. When we allow air to come through, it's going to extend the cylinder, and as soon as we remove the air, now the spring is going to force it to go back the other way. Okay, so single acting cylinder, and note there is no position indicator on this cylinder. Okay, our next cylinder here is the position verify, or they call this the vertical cylinder. Again, it has the exact same type of valve, has flow controls on both the inlet and the outlet, and it also has position verification, but it only has verification on one end of the cylinder. So we will only know when this cylinder is extended. And that's going to be important because we might need to provide provisions for that in our program. And the next cylinder we have is the transfer cylinder. And again, it has position information, but it only has it on the extend portion of the cylinder. And our last cylinder is the body feed manipulator. And again, we can see by here looking that we have position information on both sides. So we will know when this cylinder is extended or retracted. Again, both of those have metering devices on them, so we can monitor the speed that it extends at and monitor the speed that it retracts at. And again, notice the valving here is two position, and it has a single solenoid valve. So a signal to extend and then a removal of the signal will automatically force it to retract. Okay, so that is basically our input and output schematics. It's very important that you have an understanding of how those work, because that really dictates how many inputs and outputs you have to program.